Hi students, in the previous session we discussed in the unit of 4 chemical bonding and molecular structures in that bond parameters, two bond parameters. Let us continue to the part 9 to another important bond parameters. So first one, bond enthalpy. So definition of bond enthalpy means the amount of energy required to break 1 mole of bonds of a particular, very important thing is particular type between two atoms in a gaseous state. Okay, students, so here very important thing is particular type. What type of particular means? It's a single bond type of covalent bonds, either double bonds or triple bonds. This is called particular type of bonds. So bond enthalpy, the unit is kilojoules per mole. Okay, so definition is the amount of energy is required to break 1 mole of bonds. We get 1 mole of atoms, okay, of a particular type, either single bond, double bond or multiple bonds, by between the two atoms in a gaseous state. Very important thing is gaseous state. Already we told that some of the crystals having a solid state, the solid crystals is converted to some of the giving energy or heat to get gaseous state, then over to break only any type of molecules, only the gaseous states. Okay, so next we know about some examples. See here, say hydrogen gases, say hydrogen gas, it is preferred hydrogen single bond, particular type is single bond. Okay, it is breakdown to forming of gaseous hydrogen gas and hydrogen gas. Okay, so amount of energy, how much of amount of energy? Say delta H is a enthalpy. We represent delta AH because the molecules is converted to atoms. 1 mole of bond, I mean 1 mole of atom, gaseous atom, still 1 mole of atom. This is total 2 mole of atoms. Okay, so this is delta AH means atomization. The molecule will convert atom. Delta AH means atomizations. So how much value is given? So 435.8 kilojoules per mole. It is breakdown to forming of 1 mole of hydrogen atom and 1 mole of hydrogen atom. So total 2 moles. So take one more example is oxygen 2. Oxygen molecules. It is oxygen. It's a gaseous state. It is look like oxygen, double bond. So this is breakdown to forming oxygen gas and oxygen gaseous. Delta AH is, so this is higher than the hydrogen atoms, hydrogen single bonds. This is having a double bond. So delta AH is 498 kilojoules per mole. Okay, so take one more nitrogen molecules. So N triple bond, say nitrogen, 1 mole of nitrogen gas atom, say 1 mole of nitrogen gaseous atom will giving the scissor how much? 946.0 kilojoules per mole. So just observe these 3 examples. This is a single bond. This value is 435.8. It's a double bond. This is higher than the single bond values. This is triple bond. This is higher than the double bonds and single bonds. This is 946, 498, 435. So whenever the bond enthalpy is increases on the depend on the number of multiple bonds. They having the triple multiple bonds. Why we having giving a bond enthalpy is increases? Because we required so much of energy to break the molecules. Here this is single bond. Single bond is easily broken. There is small amount of energy. Having double bonds, two bonds is present. This makes giving more energy. And type of 3, this is further increases the bond character. The further is the more strong. They make giving more energy to break down. So number of bonds increases. This is the highest value because of triple bond. This depends upon number of multiple bonds. See here, these are all called homoatomic molecules. These 3 are homoatomic molecules. Homoatomic molecules same. H is OO-Na. We take one of the example of hetero. Hetero means heteroatomic molecule like different atoms. Example like HCl, it's a gaseous. It will be break down to forming H and Cl. Okay. So one cause delta H is 431.0 kilojoules per mole. It's to be easy to understand. This is a molecule having single bond, 1 mole of bond we want to get 1 mole of atoms. So we get amount of energy to require to bond a particular type. This is a single bonded type between 2 atoms in a gaseous state. It will be given 2 moles of, 1 mole of hydrogen, 1 mole of Cl. Clear? But in the type of polyatomic molecules, this is homo, same, hetero. Hetero, especially we call it diatomic because 2 atoms are present. Here also hetero, diatomic. So homodiatomic molecules. This is heterodiatomic molecules. Heterodiatomic molecules means 1 to 2 atoms are present. So we consider more than 2. It's called as polyatomic molecules. Polyatomic molecules. Let's look at for one of the example of polyatomic molecules. See here. Water molecules. Water is a polyatomic molecule. See here, the water structure already discussed in the bond length and bond angles in the previous section of the videos. This is 104.5 degree, right? So just observe this bond, OH bond. This is also OH bond. This is 2 identical bonds, right? So in the polyatomic means more than 2. This is a 2 and 1, 3 atoms are present. So how they are formed, how their bond enthalpy calculated, this is very difficult compared to homolytic and heterolytic diatomic molecules. This is very difficult. How their bond is enthalpy calculated? See here, say H2O. First, the weakest bond is broken. Weakest bond means H and OH. H and OH is broken. Something one of either these 2, any one of the H is broken. Okay. So it will be the value is delta H AH is 502 kilojoules per mole. Okay. So here one more OH gas. It will be H plus O. So this value is 427 kilojoules per mole. You think, say OH and this is also OH. This bond is broken, the value is 502. But this is also same as like OH, similar atom. But this value also given 502, right? But the value is 427 is lesser than the first broken values because they have already 2 bonds. This is highly stable. They have 2 bonds. This is more stronger. They give more energy to break the molecule Then after this is broken, so only one bond is there. They give lesser energy compared to first one. We get the value is 427. Okay, this is the reason the first value is highest than the second value. Clear? So how do you calculate these two? These two are the different values. So bond enthalpy of water, how did you identify? In this case, we consider average values. Average means mean or average bond enthalpy in the case of polyatomic molecules. So 502, these two addition and divided by 2. 502 plus 427 divided by 2 will get 464.5 kilojoules per mole. So this is a value to identify the polyatomic molecules. This is about bond enthalpy. Okay, clear? So very important thing is the number of bond having the multiple bonds is present triple bond is having the highest value of bond enthalpies. Clear? Okay. Next we go for bond order. Okay. Okay, students. Next bond order. Bond order. Okay. So bond order. The definition is bond order is given by the number of bond between the two atoms in a molecule or ion. Okay, this is the definition of bond order. Is given by how they have formed the number of bond. The number of bond is how prepared. This is prepared by electron pair, means share of electron pairs. Okay, sharing of electron pairs will be bond form. This is single bond, single atoms of single electrons pair. So two electrons are shared to forming of double bond. Triple is 3 electrons. So share number of pair of electrons between two atoms in a molecules. This is called bond order. Number of bond is present. This is the number of bond order. One bond is present. The one bond order. 2, this is 2, 3, this is 3. So, some of the examples, see here. So, H, F, and oxygen, oxygen, 2 minus. Okay. So, see here, oxygen, double bond, and say nitrogen, triple bond, nitrogen, oxygen, ion, O plus, nitrogen, oxygen plus ions. This is molecule, either ions, whatever it, we consider only the bond, number of bonds is a bond order. Okay, just look at these first examples. Okay, first example of this color examples. This is a HH, hydrogen molecule. See here, hydrogen molecule in the last we consider HH, say H gaseous and H gaseous. Will delta AH is given as 435.8 kilojoules per mole. Okay. So hydrogen molecules. This is the sharing of only one electrons. Say single bond. Electron pair is 1, bond order is 1. Say F and F, fluorine. Fluorine, his atomic number is 9. Valence atom 7. So in this 7, 1, 2, 3, 4, 5, 6, 7. Here also 7. Sharing of one electrons, they make forming of bond. Okay, but of this example, this is oxygen too. Oxygen means you look like this type. Oxygen means what? Having 6 valence electrons. 6 in that 2 more electrons is appear to sharing of bond electrons. This is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. But what about this one? How they form of single bond? Because the carbon having 6 valence electrons. In this carbon also 6 valence electrons. 6 plus 6, 12 plus 2. This is 14 electrons. Okay. So what about fluorine? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is 7, this is 7. 14 electrons. 14 electrons. So bond is single bond. This is also 14 electrons. Bond is single. Okay. So in this case, oxygen 1, 2, 3, 4, 5, 6. Okay. Oxygen 1, 2, 3, 4, 5, 6. This is single bond and is covered with 2 electrons. So total we calculate all the molecules. 6 plus 6, 12, 12 plus 2, 14 electrons. This is having only the single bond. This is called what? Isoelectric molecules or isoelectric ions. These are isoelectric molecules. This is isoelectric ion. Why we call isoelectric? Because of they have identical electrons. This is 14, 14. This is identical atoms and identical electron configuration. These to be called as identical bond order. This is isoelectric molecules or ions. Same as like this. This is oxygen, oxygen 2 and nitrogen, nitrogen giving 3 and this is carbon, oxygen also 3. Nitrogen and oxygen 3 plus ion. Okay. Isoelectric molecules such as HH, FF, OO, they give only the single bond order, they give single electrons. Same as like oxygen, oxygen, it is giving say 2 bond order. This is 1 bond order. These type of nitrogen, nitrogen, carbon, oxygen, nitrogen, oxygen, they give 3 bond orders. Clear? So one of the important term is, see here, bond order. This bond order increases, bond enthalpy increases, and bond length decreases. This is very important. How? See here, one of the example of bond order. Hydrogen, hydrogen, single bond. See here, hydrogen, hydrogen bond order is single, 1 bond order. They gave gaseous molecule, they break down to forming of, this is what? Bond enthalpy. Bond enthalpy is 435.8. Bond order increases, bond enthalpy increases, but bond length decreases. See here, double bond. The bond order increases. As usual, bond enthalpy increases, bond length decreases. How they term? So bond length decreases. See one of the example, ozone. Say 1, 2, double bond, 1, 2, 3, 4, 5, 6, 1, 2, 3. Okay. See here, ozone. This is a single bond. The bond length. The previous class we discussed about bond length. Bond length of some of the example of carbon, 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 hydrogen, carbon, oxygen, oxygen, oxygen. Just to know it. So oxygen, oxygen, single bond. They have the value of 148 picometer. Okay. Oxygen, oxygen double bond, this is 121 picometer. So, bond order increases, the bond order is 2, increases. Bond enthalpy also increases. This is a single bond 435, this is 498. Clear? And bond decreases. See here, single bond 148. Double bond 121. This is decreases. Bond length decreases. And one more example. Nitrogen molecule. This is triple bond. the value of bond order is increases. 1, 2, 3. 3 is increases. Bond enthalpy is 946. Compared to these two, this is increases. Okay students, this is very important. Clear? This is about the bond enthalpy and bond order. Okay? Clear? Okay. Next video we discuss about the remaining of bond parameters like resonance in structure and polarity of bonds. Okay? Thank you.